I am Palani Kumar, working as Assistant Professor in Kamaraj College of Engineering and Technology. Today we are going to discuss about the topic development of truncated prism in the subject engineering graphics. So we will discuss about a problem and we will solve this problem. We are going to take hexagonal prism, a hexagonal prism of base side 30 mm and axis height 60 mm, and it is resting on the base on HP with one of the faces perpendicular to VP. So this is what given in the problem. The problem is a hexagonal prism. Its base side is 30 mm, axis height is 60 mm, and it is resting on its base on HP. So we will be able to see the hexagon in the top view, and here with one of the faces is perpendicular to VP. So we need to draw one of the faces or one of the sides of the hexagon perpendicular to the XY line. And now we can move to the section plane location as given in the problem. It is cut by a section plane perpendicular to VP and inclined at 50 degree to HP, and it is meeting the axis at a distance of 10 mm from the top end. So here the cutting plane is inclined at an angle of 50 degree to the HP, and it is meeting the axis at a distance of 10 mm from the top. So we can locate the cutting plane in the given problem with these specifications given in the question. Now they have asked us to draw the development of the lateral surfaces of the lower portion of the hexagonal prism. So now we will move to the solution. Shall draw the hexagon. We can label the points. You can draw the front view. The axis height is given to be 60 mm. We can draw the axis height of 60 mm. Here the axis height is coinciding with the edge of the prism. So we will get a continuous line. We can mark the points in the front view. We can dimension the height of the prism, which is 60 mm. And now we can locate the cutting plane. The cutting plane is located at a distance of 10 mm from the top end, and it is inclined at an angle of 50 degree to HP as given in the problem. So you can measure you can draw the cutting plane at an angle of 50 degree to the horizontal plane, and it will let it meet the axis here at a distance of 10 mm from the top end as given in the problem. So let this distance be 10 mm as given in the problem. It meets the axis at a distance of 10 mm from the top end. So from the top end, the cutting plane meets the axis at a distance of 10 mm, and the section plane itself is 50 degree. It is inclined at 50 degree to the horizontal plane. Now we can mark the cutting points 1 dash, 2 dash and 3 dash. Here we are having a it is meeting, the cutting plane is meeting the edges, and here hexagonal prism, there are two edges whenever the cutting plane is intersecting. So we are able to get 6 points at all the intersecting points. We are able to get 2 points. So now we can draw all the 6 points from the front view to the top view. We can project the points to the top view, and we will be able to get the points. Here again 1 dash we will be able to get at the point A, and 6 we will get at the point F. Similarly 2 at the point B, and 5 at the point E. It will be coinciding. These points will coincide with the hexagonal prism points, and the points 3 and 4 which lies between B and C. The point 3 lies between B dash and C dash, and the point 4 dash lies between E dash and D dash. So that we can show it over here. Between B and C, the point 3 lies between between D and E, the point 4 lies as shown over here. So this is the location of the cutting plane in the top view as well as in the front view. Now we can draw the development of the prism. Here the prism is of side 30 mm. We are going to draw the development of the hexagonal prism. So hexagon consists of 6 sides, and here the side is of 30 mm. So 6 into 30 mm will give the length of the development, which is going to be 180 mm. So we need to draw the development of rectangle of length equal to 180 mm. So we can extend this front view for getting this development. Let us consider this length is equal to 180. And let us cut this 180 mm development section into 6 equal parts, as hexagon is having 6 edges. And again it starts from the point P, capital P. We use capital letters for indicating in the development. So it starts from capital P, Q, R, S, T, U, and it ends at the same point P. Now we can draw parallel lines to meet the top. And we can also mark the points. So now we can mark the cutting plane points in the development. So we can project point 1 along the cutting plane. Similarly, point 2 dash. We need not project to the point 3 dash because it is already coinciding with the top end of our development. So now we need to mark the cutting plane points in the development of the hexagonal prism. Point 1 lies in the P dash A dash. So here the point 1 lies. Similarly here in the last also we are having PA. So point 1 comes in two places, and point 6 lies in the edge UF, which is inside the bracket UF. So point 6 lies in the edge UF here. So we will come to the point, the next point 2 and 5. Here the point 2 lies in QB, Q dash B dash. So here it is QB, and from 2 we have projected it here. So here we will get the point number 2. Similarly, point 5 is coming in the edge T dash E dash. Point 5 is lying in the edge T dash E dash. So the projection of point number 5 is along here, and we have to check for TE, and TE is here. So this point will be number 5. So next we have to try to locate the points 3 and 4. Here the point 3 dash and 4 dash is intersecting the intersecting in between B dash and C dash. So it is cutting in between the edges B dash C dash. So these points can be referred from the top view. So from the top view we need to measure the location of point 3. For example, BC. Here we can see BC. How the point 3 divides this BC. We need to measure it from the scale, or by using compass we can find out how the point 3 divides BC. Accordingly, we need to locate the point 3 over here. So how in the top view the point 3 divides BC, in the same way it also divides in the development capital BC. There we are getting the point 3. Similarly, the point 4. Here the point 4 divides DE. In what ratio in the top view? Here the point 4 divides. Using a scale or compass we can find it out, and we can mark the same thing over here between D and E. The point 4 can be marked between D and E, and it is being measured from the top view as how this point 4 divides the points D and E in this particular edge of the hexagon. And now we have marked all the 6 points in the development. Now we can join all the 6 points in order to complete the development of this hexagonal prism. We need to join this by using a scale, because this is a hexagonal prism. It is not a cylinder or cone, in order to join it with the curved edges. So this must be joined by straight lines. So by using a scale we need to connect all these points 1, 2, 3, and from 3 we need to connect it to 4, and from 4 to 5, 5 to 6, and from 6 to 1, and the bottom portion will also belong to the development of the lower portion of the hexagonal prism as asked in the question. So this bottom portion this bottom portion, again I am using a violet color boundary. This violet color bounded surface will indicate the development of the lateral surfaces of the hexagonal prism. So, thank you.